At long last. It's the last section of the notes. Okay, we're not going to finish it today, but we're finally at the last section of Unit 1. Small round of applause. Okay, it's there. We're there, okay? Look, Unit 1 finishes up talking about function models and applications. This is real-world applications and using technology to do some stuff for us, all right? And that's why I said you're going to need your calculator. We're going to cover 113 today, which is function model selection and assumption articulation. Whatever. We're basically just going to be learning how to do some things on the calculator, okay? An antique dealer visited an auction house and recorded an estimated selling price of 6 different antique chests. Then he checked the actual selling price after the auction ended. The data points, which are estimate, comma, actual, so X and Y, they show the results below where the number is in the thousands of dollars. First thing we're going to do is draw a scatter plot. You might have noticed that I've already stricken through write the equation of the line. We'll talk about why in a moment, okay? Draw a scatter plot. That literally means plot these points to the best of your ability. So 12.5 comma 11 is around here. 8 comma 9.5 about there. 10.5 comma 12, that barely fits on the paper. This thing goes up to y equals 12, but barely fits. 10.5 comma 12. 5 comma 3.9. It's there-ish. Dot's fat enough, it's hard to argue. 9 comma 10, at least those are whole numbers. And lastly, 7 comma 6.5. 7 comma 6.5. That is a scatter plot. So what is a trend line, also known as a line of fit by eye? It is a straight line that does its best to go through all of the data points. Now, that's obviously not possible. You're not going to be able to get through all of those data points with one straight line because, well, they don't fall in a straight line. So you do your best with the trend line, and you try to have it go through some of the data points, and if that's not possible, have it get close to as many of the data points as possible, and do your best to have an equivalent number of dots above the line and below the line. So I grabbed a clear ruler so that I could, and that's not even very good, so let me lay it on its side, and I don't know, something like here-ish, looks like it. Let's see, it would have 3 dots above it, 3 dots below it. It gets really close to that one that's kind of in the middle. I'm just going to draw a line. And notice that this wasn't too highly mathematical, right? It's called the line of fit by eye, or a trend line. That doesn't even look straight. Did I use the wiggly edge of the ruler? I think I did. Crap. I'm not sure. Might just be a trick of my eyes. Now part B says, and by the way, yours doesn't need to look exactly like mine. Just try to get relatively close to all the dots with one straight line with the same amount above and below. Okay. We are not going to write the equation of a trend line, which is the same thing as saying we're not going to write the equation of the line of fit by eye. Reason why is because there's an infinite number of correct-ish trend lines. It's what looks best to your eyes, what looks best to my eyes. There's even rules that are like you're supposed to find the average X and the average Y, and the line you draw has to go through that coordinate of the average X and the average Y. And then you're supposed to try to go through one of the other points and find the slope between that average point, and it's too much. It's too much. You won't be asked to do that for AP. It's just important that you know what you're looking at. This is a trend line, and you can see that this data is relatively linear because that straight line did a pretty good job of getting close to all of those, right? Cool with that? Awesome. What if we wanted the equation of the line of best fit? That's not the same as a trend line or the line of best fit by eye. It's the linear regression, literally the line of best fit. We use our calculators. The calculator will do this for us. This is going to be a very long string of instructions. Please pay close attention and go along with me, okay? Turn your calculators on. First of all, don't worry about that. We'll get to that later. I'm going to go ahead and clear everything that's in my screens. If you have anything in your y equals menu, go ahead and clear it out like I just did. All right, here we go. We need to essentially find the spreadsheet of our calculator so we can enter these as x's and y's. Here's where that is. Stat. You'll notice when you enter stat, the very first thing that's highlighted is edit. You hit enter. This will get you to your lists. You will notice that my lists already have numbers in them. If your lists already have numbers in them, like mine do, then you need to clear those out. Are you already lost? Okay. Here's how you clear them if you have data in there already. Go up to L1. Do not hit delete. Hit clear, and then enter. And it'll clear the entire list. Go over to L2, clear, enter. It'll clear the entire list. Has anybody in the room already accidentally deleted an L1 or an L2 and it no longer exists on their screen? Nobody? So I don't have to show you in the video how to bring that back. Great. All right. You're going to type these in. To get down to the next cell, so 12.5, to get down to the next cell, you can either hit the down arrow or you can just hit enter. I'm a fan of enter. So just type your X values, hitting enter after each one. Be careful. Make sure that you are typing it perfectly. You're not fat fingering the keys. You're not missing any decimal points, nothing like that. These are our Y values. You want your Y values to go into L2, list 2. You want your X values most of the time to be in list 1. So I'm going to go over to L2 with the right arrow, and then I'm going to type those numbers, hitting enter after each one, making sure that I typed it correct as I go, not fat fingering the keys. What do you see? Slow is smooth and smooth is fast? All right. There it is. Is there anybody that needs more time filling out L1 and L2? Okay, now you're all ready for the next command. At this point, we're going to ask this calculator to do some mathematics with these lists. So hit stat again, and you're going to scroll over to the calculate menu. This is all the mathematics, and I'm sure there's more, but everything in here is mathematics that this calculator can do with lists of data. We are going to ask it to make an equation of a line, y equals mx plus b. If you look at command 4, you will see something that looks like mx plus b. This is called linear regression. Those of you that read quickly might have noticed that number 8 also says linreg, but it says a plus bx. I don't know what that's used for. I don't think I've ever used it before. So we will never use whatever the heck that is. We won't. Okay? So you can either scroll down to 4 and then hit enter, or you can just type the number 4, whatever you want to do. Everybody's screen should look like this now. Notice that the calculator defaulted to make L1 your X's and L2 your Y's. Is there anybody's that has something different there? Nobody's. Okay. Scroll down. Frequency list should have absolutely nothing typed. If there's something there, hit clear. There needs to be nothing there. This is for probability and statistics, not for what we're doing right now. Yes?
I accidentally hit clear on the next list.
Bring it up. Because we can type L1. So, L1 is down here. And it's a blue thing. So you hit second, 1, and L1 is back. L2 is right next to it above the number 2. So in case you do that, there you go. That wasn't, you know what? No one in the last period did that. So last period, now they're going to go home, and if they make that mistake at home, they won't know how to fix it. Hopefully they know to go to YouTube or something. Okay. Because I'm teaching you how to do a lot of stuff with this calculator today, go down to the next one. This is the store command of your regression equation. What this is going to do is we're going to use this to keep the equation it's about to give us in its memory. More buttons that you've probably never pressed before. This button right here says vars, stands for variables. Hit vars. We are going to be getting a y equals mx plus b out of this, correct? So we're going to go to the y variables. And since it is a straight line, we know it is a function, so we'll hit enter on the function. And we have all of these options. You might as well just hit enter on y1. What this is going to do is copy paste the equation that we're about to find into our y equals menu. So instead of us having to write it all down and then type it in ourselves, it's going to put it there for us now. We go down to calculate and we hit enter. Boop! It did some flashing and some stuff popped up on the screen. Now some of you might have noticed that my screen has more information on it than theirs does. I need someone to bring me one of their calculators that does not show r squared and r so I can fix it and the rest of you will follow the same lead. Gavin, you this time? Okay. And does yours show this information? It does, because your calculator is different from theirs. Okay. Is there any... Ariana, how's that calculator? Does it show r squared and r? I know. Ariana, does yours show it? Okay. So and that's the older version of the calculator. Is there anybody else that has the older version of the calculator that doesn't show r squared and r? No? Okay, I'll just fix that one for you in a moment. Okay. Here's how you're going to do that. Everybody that's missing r squared and r. You're going to press mode, which is right here. And this won't work for Ariana's calculator more than likely. Try anyway, see if it's there. And scroll down to where it says stat diagnostics. That needs to be turned on. So scroll over to on and hit enter. Now I'm going to go stat, calc, linreg. I'm just redoing it to bring all the information back. Vars, yvars, function, y1, calculate, and there it is. You don't need r squared and r for this question. I just wanted to make sure that for the future, your calculators show it. Okay? Gavin, there you go. Yes? When you say it's not working, what do you mean?
Like I'm pressing enter and it's not going back.
Let me see it. Oh, you have to hit second mode, which is your quit button.
Oh.
Okay? So see stat, calc, linreg, vars, vars, yvars, function, y1. There you go. Now it works. Okay, great. If you press y equals, boop, you will notice that the calculator has put the equation there for us. Pretty neat, huh? It's there for us. Everybody has this equation in their y1, correct? What we're going to do now is we're going to have the calculator put the scatter plot and this equation on the same picture. Here's how you do that. Scroll up. You should now be on plot 1. Hit enter. That will turn the scatter plots on. We are not going to hit graph though. Don't hit graph, please. Instead, go to window. Reason why? Because this is our window. It doesn't need to be ridiculously large. So for the x's, I don't know, 0 to 15. Might as well count by ones. For the y's, how about we just go to 0 to 15 again? Get a nice square window. Now when we hit graph, we're going to see these dots and it's going to draw the line of best fit, the linear regression. I went from 0 to 15 on the x and the y. Oh, Ariana, did it fix? Okay, so that one has an updated operating system even though it's an older version of the calculator. Perfect. Perfect. Otherwise, I was going to have to go digging in the catalog of files and turn it on like I did last period for somebody. So we good? Hit graph. Boink. and you have a trend line and those dots, and look how good my equation, my line of best fit by I was. That's pretty stinking good. It's pretty close. Is there anybody's calculator that doesn't have this on the screen right now? Okay, let's take a peekaboo at it and see what went wrong. And just in case it needs to be in the video, keep recording. Let's see. Uh-oh, window range. Okay, so what that means is you forgot a negative sign somewhere. You went 0 to 15, and then you went from 15 to 1. You just switched your minimum and maximums. That's why. There you go. So when you see window range, that usually means that you either use the same number for the minimum and the maximum, or you swapped the two numbers. So you'll get that error. So there it is. Cool, huh? That's it. Now, I know that that's a whole lot of instructions. Good news for everyone. If you look at the next page, it is everything that I just showed you, and a way to even edit the way the stat plot looks. If you wanted to have like bar graphs, or you wanted to change the way the points look, it's all there. That's the instructions for the TI-84. Yes? No. You have to know how to do this stuff. Don't worry. You're going to actually do the homework and practice using the calculator over and over and over again. Now, this page is if you have a TI Inspire, and none of you does, so don't even worry about that, okay? All right. Let's do it again. So I'm going to go to my y equals, and pay attention, please. Clear your equation, go up to plot 1, and hit enter to please shut the scatter plot off. Otherwise, it might throw errors when you try to graph next, or it'll have dots that don't make any sense at all for the line that you get, okay? So just go ahead and turn the stat plot off. We don't need to... It's not highlighted. If it's highlighted, it's on, okay? You don't need scatter plots turned on for what we're about to do. I just wanted you to see how to do it, yes?
Mine's still highlighted, like it's not going on, even when I press enter.
You went up to plot 1 and hit enter?
Yeah.
And then scrolled away from it?
Yeah.
And it's still on?
Yeah.
Let me see.
It didn't work for me.
You didn't press, maybe your enter button's sticky, I don't know. Okay, there, let's go ahead and do it again. This is going to be our x's, this is going to be our y's. Let's talk about what this, it says, let's use a graphing utility to draw a scatter plot, then create a line of best fit to analyze the data in the table below. We don't need the scatter plot. What good is the scatter plot for us? All it's going to show us is that the line it draws is pretty darn close to most of the dots and relatively the same number of dots as above and below the line. So we don't even need to bother with the scatter plot. It says write a linear regression model for the price of oranges in dollars per box. This is our X list, which is Y1. This is our Y list, which is YL2, excuse me. And just be careful with your decimals. So again, to get to the lists, stat, edit. To clear them, you highlight the L1 or L2 and hit clear, enter. And Max wanted to know if he could have all of these paper instructions to use during the test. No, because you will do this so many times that it will become muscle memory. I mean, it's like second trace intersect, which, you know, is how you figure out what two graphs cross each other. Second, or a stat edit, stat calc, lin reg, like they just become very normal things for you to do because you will do them a lot. Okay, I'm going to fill out my X list with the years. There. 6, 7, 8, 9, 10, 11, 12. Those are the years, 2006 through 2012. Just in case you don't know, if it ends in a 0, you know you don't have to type that 0. The calculator doesn't know you're typing dollars. There it is. we've been tasked with coming up with an equation for this. Obviously, we're going to let the calculator do it for us. Everybody had a chance to type these two lists of data in? It's always funny when we come to the next test, you can tell when we're doing this on the test because the room is always really quiet, but you can hear all the buttons in the room clicking. It's awesome. It's like the nerdiest ASMR there is. Just buttons clicking at no pattern, random intervals. Sometimes there's a little bit of crying involved. So anyway, so stat, calc, lin reg, hit enter. We don't have a reason to store this one. And here's why. We've been asked to write down the equation. And then we've been asked to use it. So here's what's up with that. You know that we're probably going to get a bunch of decimals in our slope and our y-intercept, just like we did a minute ago. But we always round to 3 decimals for AP. So when it asks you to use the model, you need to use the model that has the rounded numbers in it. So we're not going to use the exact equation that the calculator predicts right here. We're going to take the equation it predicts and we're going to round everything to 3 decimals. So I'm not even going to bother storing it this time. We got the X list, we got the Y list. We don't have a reason to store it. I'm just going to go down to calculate. Boop, there it is. Oh, wow. That is not a good model. Maybe that's why we were supposed to see the scatter plot. Okay, I'm going to redact what I said in just a moment. We're going to actually get the scatter plot. But let's write down our model, okay? And since it's talking about oranges, I'll write in orange. Y equals 0.357x minus 705.683. Now, you probably don't have enough knowledge to know how I knew that that was a bad model, unless you've taken a stats course. But what we're going to do now is we're going to go back through stat and calc. We're going to redo it, and this time we're going to store it because I do want it to graph it, and I want it to graph it with its scatter plot. So vars, y bars, function, y1. Then I'm going to calculate. Please don't hit graph. We need to go to our window. Actually, let's go to y equals and turn our scatter plot on. Plot's on. So just go up there, highlight it, hit enter. Watch out for sticky enter keys. Then hit window. Because look at these x values. You see these things? They start at 2006. I don't know. Want to start at the year 2000? And go to the year 20... Well, eventually we're going to go to 2015. So let's just take it up to 2015. That's only 15 tick marks. That's like saying go from 0 to 15. So a scale of 1 is fine. Now, our smallest y value was $8.40. So you thinking like $8? We go to 8. Our biggest y value is $13.12. 15? Okay, it's already on 15. Okay, there we go. So 8 to 15? Oh, $15.99. Oh, crap. Yeah, look at that. Nah, screw it. 16, whatever. Now, when we hit graph, we're going to see our scatter plot. Look at that plot. Notice how it didn't really have a straight line shape to it. And that was the best that the math would allow the calculator to do. Remarkably far away from a lot of the data points. That's how you know you're looking at a not very good model. It would appear as though this data is not really linear data. But we're doing what we're told to do. We were told, get a linear equation. There it is. This is so you can see that this is actually not a very good model, is it? Data is kind of all over the place. not an obvious linear pattern like these were, you know. When we get later into the material, I believe it's unit 2.6, we will talk more about how you know you're looking at a good model or how you know you're looking at a better model than another one. Right now, we're just learning how to get the models and then use them. We good with that? Yes, Mr. Ram. Okay, great. Now, here's what we're going to do. We're going to use this equation to estimate the price of a box of oranges in 2014 and 2015. Cool with that? How are we going to do that? These are X values. We're just going to plug them in. That's it. So 0.357 times 2014 minus 705.683. And we'll do it again, but with the number 2015. Okay, I'm just going to hit clear. Get me back to my main screen. I hit clear. 0.0375 parentheses 2014 parentheses minus 705.683 is. Something went wrong. You guys see what it is? 0.0375 instead of 0.375. So here's how we're going to do that. 0 decimal, hit enter again. There we go. Much better. I feel like I had a different answer last period. My goodness, I am just bad at my job. Third time's a charm. There we go. 13.32, because it's money, we need to round to 2 decimals. $13.32. And for the next one, I'm not going to retype it all. I'm just going to go up, highlight, hit enter, and I'm going to change that 2014 to 2015, hit enter one last time. 13.67. So even though it's not a good model, we've used it to predict the prices of oranges in the future. Cool with that? Not too crazy hard, right? I mean, literally knowing what buttons to press. That's the hard part, right? Don't worry, muscle memory, you will get used to it. And until you are super duper used to it, you will follow the directions on this page. And you don't need to do this stuff here. You don't need to mess around with what the scatter plot looks like. You do not have a TI Inspire. Moving on to the last example for the day. Ooh, quadratic models. U-shaped graphs. Fun. No, fun. No, super fun. Because we're not going to do any actual mathematics. We're going to let the calculator do all the math for us. So hopefully you're paying attention to the video because there won't be much written in the notes. First thing we're going to need to do is go back to our Excel spreadsheet, so to speak, which is in Stat Edit. Clear these 2 lists out and enter these 2 lists. And this one's talking about the height of transmission fluid that is draining from a storage tank. So time will be our independent variable, our x, and I'll probably write it as t, just so. And we'll use h of t. It's going to be our y list, our L2, our dependent. Okay. 10-second intervals. And please remember that when you answer these kinds of questions, your answers do require units. You won't get full credit if you don't write units because it's AP. There it is. The directions this time do not say to find the equation of a linear model. It says model the data with a quadratic function. The good news is it's found in the exact same place as linear regression. This is just called quad regression, as in quadratic regression. So stat, calc, and just scroll down until you see quad regression, which is number 5. You'll notice it also has cubic regression, quartic regression, it has natural log regression, it has exponential regression. Got a bunch of fun stuff in it. So we're trying to do quadratic regression right now, and this is going to give us the equation of a quadratic, the equation of a parabola, in standard form, ax squared plus by plus c. Right? No. Ax squared plus bx plus c. There we go. I said the wrong letter. Boop. Anyway, make sure you have your first list, L1 is your x's, your second list, L2 is your y's, and man, yeah, there is no reason to store it. Actually, you know what? Let's go ahead and store it and see what the scatter plot looks like. Let's see if a quadratic model is a good model. What do you think? So let's store it as, so vars, y bars, function, y1. And then we'll hit calculate. Wow. Yes, it's a very good model. And let's write it, rounding everything to 3 decimals. So h of t, our height over time is, I guess I could define my variables, right? Okay, I just added t and h of t. Our height over time is 0.008x squared minus 2.082x plus 123.119. And just like in the last example, what I'm going to do now is I'm going to make sure that my scatter plot is turned on. So I'll go to y equals. I see plot 1 is on. I see that it copy pasted the formula for me. I'm going to go to the window and I'm going to make the window fit. Our time goes from 0 to 60, but if I just do 0 to 60, it's going to put dots on the edge of the screen. That's kind of hard to see. So even though there's no such thing as negative time, I'm going to have it start at -10. And even though we don't have data that goes out that far, I'm going to have it go all the way out to 70 seconds. And that's just so I don't end up with my scatter plot dots on the edge of the screen. That's the only reason why I'm doing that. I guess we could count by tens. Sure, let's count by tens. You can count by tens or fives or whatever. Now your y values, I mean, that's the smallest one, and that's the highest one because, well, this thing is draining over time, isn't it? But I'd kind of like to see the whole picture, if you would. So again, even though there's not a possibility for negative heights, I'm going to dip below this to like -10 or something like that. And I'll go up as high as, I don't know, we think like 140? Yeah. Okay. So let's go from, say, -10 up to 140-ish. I don't know. I didn't get the scatter plot last period, so I'm kind of guessing right now. Obviously, our scale can't be ones, but it can go by tens pretty well. And when we hit graph, we're going to have some dots, and we're going to have a parabola, and you're going to see that that parabola gets really close to those dots. Can I hit graph? Then your scatter plot is not turned on. Go to y equals. Go up to plot 1, highlight it, hit enter. That work? Okay, great. It says use this model to estimate the height of transmission fluid in the tank at 35 seconds. That means plug in time equals 35 there and there. Is transmission fluid is red, isn't it? Like really deep red? Any gearheads in the room? Isn't transmission fluid red? I'm pretty sure it kind of looks like blood. Yeah, good, like really dark cough medicine. Yeah. So I'm going to write in red. and I have to type that in, unfortunately. Three decimals, 60.049 inches. Great. The last question says, how long will it take to drain the storage tank? So if I drain the storage tank, what do I know to be true? The height is 0. If you go back to your graph, you will notice that we can't see when this graph hits a height of 0. It's further that way, isn't it? Now, we could try to solve this using the quadratic formula if we hate ourselves. But we don't hate ourselves. So what are we going to do? First, I'm going to go into y equals, and I'm going to turn the scatter plot off because I don't need it anymore. That was only on just to see if it was a good model, right? I don't want to use what is typed in. I want to use this model because this is what I used to estimate this. So I need to use this model to estimate this. So I am going to clear it out. Again, it was only in there so we could see that it was a darn good model. I'm going to type this in. Now you guys told me that the height is 0. This right here? Right there? Okay. Anyway, you guys told me that the height was 0. So I'm going to go to the next line down at y2, and I'm going to type 0. We're going to do second trace intersect. We're going to figure out where our quadratic model hits the x-axis. But remember in the image I had just a second ago, our graph didn't go far enough to the right, did it? So go to your window, and just have x get bigger. How big do you want to go? 90? How about we go to 100 just so it's a nice round number, okay? Might as well keep it tens, and we don't need to see, like the y values don't need to change. We just need to go further bit to the right, correct? And hopefully 100 is big enough. I don't even know. I just chose 100 because it's a big, nice round number. So we hit graph. It's going to redraw our new model. Uh-oh, is it going to hit? Whew, barely. Okay, it did hit, but barely. But look, it was way out there close to 90. So I'm glad I went out to 100 because that might not have fit on the screen. Second, trace, intersect to figure out where the height hits 0. Second, trace, intersect is command 5. You hit 5. There's only 2 equations on the screen. So you hit enter to say, yep, the first one. You hit enter to say, yep, that second one. And then you just scroll over to where the answer is just about and hit enter one last time. Boom, baby. Looks like it's going to happen right around 90.849 seconds.
I only have one line.
Did you type in y2 equals 0? He did not. Cooper. You could do second trace 0 also, but then you have to do to the left of the answer, to the right of the answer, and then click somewhere in between. I just kind of have second trace intersect as muscle memory, second trace 5. It's just faster. I just think it's less button clicks. But you could do second trace 0 if you like. It works as well. It'll give you the exact same answer, I promise. So 90 point, so let's do like this. H of t equals 0 at time equals 90.849 seconds. Remember, you need units. If you don't use your units, you will not get full credit. But that, folks, is all she wrote.